Okay, this is the rest of lecture 5, the stuff that we didn't get to before class ended. So I figured I would make another video talking about this stuff because some of it does show up on Pearson and it does merit some more explanation. So real quick, let's recap this one. So this time we were given a function that was written in vertex form. We like this because it's easy to graph. It's also easy to solve equal to things. So real quick, let's just hit up A, B, and C. First up, to find the vertex, when you're given something that's in vertex form, is you just need to identify what your h and your k are. So looking at this, this is plain vertex form. That would be what it is. And this is what I was given. So just by lining up the pieces, we can already figure out a few things. My a value, which is the coefficient to those parentheses, my a value is 2. My h value is also 2, and my k value is 3. So my vertex, which is given as hk, should be equal to 2, 3. Or in other words, my h is equal to 2. H is equal to 2 means that my line of symmetry is x equals 2. That's going to be my line of symmetry. So you can see I've graphed that here on the picture, and I've also graphed the vertex 2, 3. So I'm going to go to 2 and then go up to 3 and plot my vertex right there. And because my a value is 2 and 2 is positive, that means that this picture is concave up. It looks like a U shape and not a sad face. It's going to go basically up. And this is a quick little sketch of the graph. If I wanted a better picture, I could plug in maybe 0 or plug in some other points around here, so that way I have a better idea of how this arcs upward, but this is totally fine for just a generic sketch. Okay, so what if I go the other way around? They gave me a function in vertex form and they said, draw it, come up with the graph. What if I have the graph and I need to come up with the function? There's two main ways that you can do this. You can do this if you have any 3 points that are on the parabola, or you're allowed to use 2 points as long as one of those points is the vertex. You're always going to be dealing with the first situation where you're always going to have a vertex and another point. They're not going to make you solve yet for the equation of a parabola with 3 non-vertex points. You'll do that later, but for right now, you're just going to have a vertex and another point. So how do I do that? Well, first up, I want to start off with the template for vertex form. This is what vertex form looks like. Normally this is H and this is K. And then I want to take my vertex and plug it in. I know that H should be 3, and I know K is supposed to be negative 13. So I'm just putting those where those points go in the formula. The other thing they gave me was a random point that's on the parabola. Remember, this is a combination of an x value and a y value. So what I can do next is basically replace that in my function. I know my x is supposed to be 0, and when I plug 0 in, I'm supposed to get out negative 4. So I can swap out f of x with negative 4 and x with 0. Remember, y and f of x mean the same thing. They just look different, basically. At this point, though, I have an equation that is all numbers except for a. I know everything except for the a value. So I can actually solve for it. I can figure out what the a value is supposed to be because I know everything else. So 0 minus 3 is going to be negative 3, and I'm going to add 13 to both sides. So I'm going to have plus 13 here. And at this point, I'm going to get rid of the colors because they're not helping anymore. So negative 4 plus 13 is positive 9. Negative 3 squared is also positive 9. And now I can divide both sides by 9 to get 1. So A is actually equal to 1. Now I'm going to go back to my vertex form since I have everything I need. Okay. So vertex form needs 3 things. It needs A, H, and K, and I know all of them. This is supposed to be 3. This was supposed to be negative 13. And I just found out that my A is supposed to be 1. So this is my finalized vertex form. However, in practice, it's a little silly to write this as multiply by 1, so oftentimes you'll see that deleted, where you won't actually be writing a 1 in front of the parentheses. You could if you wanted to, and it's not wrong, but it's more pretty to just leave off the 1 if you don't need to write it. Okay? Next up, I want to talk about solving quadratic inequalities. This is the other main topic that is on the Pearson homework that requires additional explanation. So solving inequalities starts off just the same way as solving equations. What you basically want to do is pretend that this less than sign is an equal sign and proceed to solve that as normal. So that's what I started doing here. If I wanted to solve this with an equal sign instead of a less than, first thing I'd have to do is get everything to one side. So I moved over the 5x and the 7 to the other side, and then I decided I wanted to factor this. However, you didn't have to do that. If you didn't want to factor this, you could have used quadratic formula, you could have used completing the square, or even like the square root method or something, whatever floats your boat. However, I chose to factor this, and I ended up with this result. And this one ended up being important for later, so I'm going to go ahead and emphasize that with a highlight. Bit of an awkward highlight, but that's fine. And now I pretended like this was equal to 0 and solved for my x values. And I got 1, and this is -3.5, but you could leave it as -7/2. But these would both be my answers. So here's where the difference shows up. At this point, what I want to do is I want to take those answers and plot them on a number line. And now at this point, what I want to do is check to see what the function is doing in between those kind of cuts on the number line. We call these things critical points, and essentially these spots are where the function switches from either being positive to negative or negative to positive. This is basically like some kind of turning point. And I just don't know which way it's turning, right? I don't know whether this is positive or negative over here. I know it hits 0. But then what does it do, right? Does it go back to positive or does it go back to negative? I don't know. We got to find out. So what I want to do is I need to pick a test point in each interval. And it doesn't matter what you want to pick. So I just made some choices here. These are arbitrary choices. As long as you pick something that lives in these intervals, you're good to go. And just for the record, out here would be like -infinity, and out here would be like infinity. So you have really anything you want within those, or within 1 to infinity. So I was pretty basic, and I just picked -10. I chose to pick -10 over here, so I'll mark it like maybe over there. It's not a critical point, but that's what I chose. So if I pick -10 for this interval, I'm going to plug it into here, and this would be -10, -10 over here. I'm plugging it into the factored version because all I really care about is whether or not the answer is positive. I don't necessarily care about what the number is. So I'm going to go find the number, but I don't actually really need it. So this is going to be -10 times -13, which is going to end up being 143, and 143 is positive. I don't necessarily care that the number is 143. I just care that 143 is a positive number. So I know for x values that are between this number and this number, or between -3.5 and -infinity, my function is positive. Okay. And now for my next one, I need to pick a test value that lives somewhere in this interval. And I'm pretty basic, so I just chose the easiest number I could plug in that lives between -3.5 and 1, and that was 0. So I would do 0 minus 1, which is -1, times 7, because I'm plugging in 0, and this gives me -7. I don't necessarily care that my answer is -7. I care that it is negative. So if I plug in values that live in between this and this, my answer will always come out to be negative. And finally, for the last one, I just chose 2, but anything that was bigger than 1 would work. You could pick 100 if you wanted to. I just chose 2. So if I do that, I'll get 1 times 4. And I get 4 from, oh, sorry, not 4, I lied. This would be 4 plus 7, so that would be 11. So my answer comes out to be 11 when I plug in 2. Again, I don't really necessarily care that my answer is 11. I care that it is a positive number. So this is going to get marked with a plus. And now I have to go back to my question. So my question originally started off as this. However, I did a bunch of algebra and changed my question into this one. And this is the one that's more convenient to solve. So this is essentially asking me, What type of x values will give me a negative answer? What kind of x values do I have to plug in to get out something less than 0? And I just found those. The type of x values that I'd have to plug in, those are here. I would have to plug in numbers in between this and this. So my answer is going to end up being, you could write it two ways. Here's one way. Or I could write it this way, where I have parentheses. Whoa, those are terrible parentheses. And why do I have parentheses? Well, it's because this is a strict less than. So I don't care about values that are at 7/2 or -7/2, because this will exactly give me out 0. Plugging in 1 will exactly give me out 0. Not a 1 exactly 0. I want only less than 0. So I do not include those endpoints. These are the two different ways to write my answer. Why did I pick this middle interval? Because it was asking for numbers less than 0, or it was asking for negative numbers. We'll be doing a lot more of this later when we hit higher degree polynomials. This is a technique that gets used a lot. However, you could have also solved these on a graph. So if I recall the question, this was what I was originally given. I decided to say, okay, well, this left-hand side over here, I'm going to make this left-hand side into f. And I'm going to make this right-hand side into a g. And then I just asked Desmos to shade in the area where f is less than g. That's exactly what it asked me to do in the question. And you can see that Desmos highlights the region where that's true for you. And this is from -3.5 up to 1. Just a little hard to see because my graph doesn't include those grid lines. But you'd be able to verify that for yourself by checking it out on Desmos. You can just click this link in the slides. However, you also don't need Desmos to spoon feed you the answer. You can do this yourself from a picture. What this is really asking when you have something like g greater than f or f greater than g, what this is really asking you is, when is my g bigger than my f? Or in other words, when is my g above f on the number line or on the graph? So let's take a look at when that happens. Yeah, I'm going to use yellow. So or rather use yellow for this. Okay, so starting from left to right, I can see that over here, my parabola, which is f, that is above my red line, all the way up until right there. At this point, the parabola dips below the red line. So this right here is the region where the red line G is above blue. And that happens right up until this point right here. So this yellow region is where the red line is above the blue parabola. That's going to be the answer to number 1. So red line above parabola. When does that happen? From -2 to 4. So I would say, actually, this can be bracket from -2 to 4. Why bracket? Because I'm allowing places where they're equal, and they are equal at these little crossings. Okay, so as for the other one, remember this is answering the question when this time is the parabola above the line. Parabola is above the line over here and kind of onwards back. If the picture continued, you'd be able to see that the parabola is still above the line forever towards the left. So that would be true from here backwards. Same thing is sort of true on the right. After this point right here, my parabola is above the line. Parabola and line. See, parabola is above it. So here's the other place where that's true. So in this case, I'm going to have to answer using the funky U symbol. That would have to be, okay, everything from -infinity all the way up to -2. Parentheses, because I don't have the bar underneath there. Union, everything from 4 onwards to infinity. Okay. So you don't have to rely on Desmos spoon feeding you the answers. You can also just look at the graph and deduce these things for yourself. It takes a little bit to see it though. So thank you for watching. This is all we missed on either Tuesday or Wednesday, depending on which class you're in. So if you're having trouble with this on Pearson, just shoot me an email or shoot me a message. And I'll be more than happy to go over anything regarding all of this. All right, take care.